Daniel Holker from Kentucky Transportation Cabinet.
Hey Daniel, this is Bruce Lambert. I switched my phone to the speakerphone in case anybody needed to call me.
Okay.
So we're in good shape. Just gotta let everybody else get ready to join in the fun and frivolity.
We're waiting for a few people on our end to join, and hopefully at 1 o'clock we'll be ready. And if everyone else is ready, we'll get started.
Well, what I'll probably do, Daniel, is I'll probably do just like a general, hey, who's here, few minutes. I'm never going to take the screen from you. I will leave you in charge of that. But for the most part, I'm just going to ask, who's here, tell us a little bit about how you used it or not used it. And then once that's done, I'll turn it over to you. And my goal is, to be honest with you, starting with content, after about 3 or 4 minutes.
Okay.
I always hate it when I do a webinar or whatever and waiting for that 1 or 2 stragglers. Well, sorry. Please go.
Can you see the slide changes?
Right now, all I see is Kentucky here, link, location, procedures. Oh, wait. Yeah, I see it.
Okay. Just wanted to make sure.
Yeah, no, I mean, that's why, Daniel, I'm glad that you blocked out the hour beforehand, because I've always hated when, I'm not used to, I've used it before, but I'm not an expert in it, so. Always like to be, know it's going to work.
If you'll give me just a few minutes to round up some people from our end, and I'll be right
Daniel,
back.
I'm staying on the phone right now. I'm not going anywhere. Do what you need to do, and people get online, I'll amuse them, and I'll tell them bad jokes. And not like offensive jokes, just bad jokes. Hello?
Hey, this is Jared Casal with DOT.
Jared, how's it going?
Good.
Yeah, I apologize for the delays, and then I forgot to send out the actual link to download the free conference server, so it does make a difference if you actually want to see the slides. So.
Yeah, I got right in. I never downloaded anything. It's the first time I used it too, so.
It's pretty easy. I mean, that's why I use it, because it's pretty straightforward. But you'd be surprised at how easy. I tell people, stick a CD in, hit start, and within 10 minutes, their whole machine crapped out, and they're yeah. Actually, it's one person, my wife, so I gotta be careful sometimes. So anyway. So we have somebody else join us? So are y'all ready for Labor Day?
Oh yeah, it's coming soon. Hey, real quick, this is Jared again. I can do the first 30 minutes, but I got to step out and I had a prior engagement at 2:30.
No, that's fine, because what I was going to talk to Daniel about is to see if there's going to be any follow-up, or if people have specific questions, then they should be able to call him up directly.
Yeah. Hey, this is Daniel. I will have my contact information at the end of the presentation, and I'll also send the presentation to you afterwards, so people will have my information if they have any questions. We're already from Kentucky.
Okay. I just got an email from Eric Johnson. He said he was having problems. The server was out, so I don't know what's going on. I know Florida had several people, as well as Georgia had somebody who wanted to participate. So we'll see what happens.
Hey, Bruce?
Yes.
Eric's here.
Yeah, I saw you called in, but I don't know if you got on the server page or not.
I have, wait a minute. Now I got two things going on. What's this? Well, I got is this just a phone call online?
No, it's a phone call, and it's also got a microphone. So I'm actually disabling my microphone right now as well.
But there's no presentation or anything like that, right?
No, there is a presentation. Daniel's giving it in just a few minutes.
Well, okay. So he hasn't put it up there yet, though.
No, you should see a screen that says KYTC here link location procedures. Jared, do you see the screen?
Wait a minute.
Yeah, I see the procedure screen, the KYTC here link location procedures.
Okay.
See, it's weird. I'm in, but I can't see. I'm in the phone call, and I see everybody's list, name and everything, but I can't see the presentation.
Eric, I don't know what to tell you. This is the same software that you called in when we were in Little Rock.
Uh-huh. Well, I don't know. I think I used the phone last time. I just called that.
Okay.
Now I'm on the computer. It says something here about view wall, and when I click on that, it goes to a web page with a join online meeting, and I thought I was.
That's it. Join it. Join. She give you 3 options: download, join, or something.
Well, I was already in. It says, "You want to leave this meeting to join another one."
I don't know what to tell you, Eric. I mean, I
downloaded the file. This is Daniel. I downloaded the file and installed it, and it seems to be running fine with me.
Okay, I got it this time.
Well, what did you do to get it, Eric? I'm just
Oops.
curious.
Dang.
I'm sorry?
Sorry. Seemed to go back and forth. I had the presentation. It was on one tab, and this other thing was on the other tab. I went to close a tab, and I lost the presentation. No, it shouldn't have been that one. So I'm going to try it again. I'm back. Is everybody in? Is everybody in yet?
I mean, I think everybody, we're about to do a roll call, Eric, but I haven't heard anybody else complain about not being able to connect.
Okay, well, I think I got it now. This is just different than anything else I've used before.
I'm sorry, I went the free route.
It's okay. It's just a different setup.
Okay, well, I'm going to... Daniel, you said everybody in Kentucky is ready to go?
Yes, we are.
Okay, well then, as far as I know, I think we should just go ahead and get started. Just to give everybody, again, some background, when we were in Little Rock this summer, Daniel and Laura discussed, and then they approached me about doing a webinar on how Kentucky was solving the linear referencing issues or problems or challenges associated with the HERE data set and snapping it to their network. And so I thought that'd be a great topic. It's very specialized, but I thought it'd be a great topic, especially as more and more people are recognizing that federal highways will probably be making the HERE data set or some version of it part of the performance measures going forward. So I thought it was very timely that Daniel would offer that suggestion to us, and I jumped on it right away. Just for my own sake, who has all called in or attended? I know, Eric, I got you from Virginia, and Jared, I got you from Florida. Anybody else from another state?
Arkansas is here.
Hey, Virginia.
Hey.
Got a few folks from GDOT.
GDOT, okay. Is that Stan, that you?
Yeah, that's me. Tom's actually not with us right now.
That's not a good way of saying things in the South.
I didn't mean it like that.
You got Sean Davis and Eric Songer with Florida DOT.
Okay. Okay, anybody else? Okay. Well, as far as I'm concerned, Daniel, you have the screen, you have control of the monitor. I'm going to put it on mute. And the way Daniel and I were talking about this is this is a very technical presentation. If you have questions, please ask, and so that Daniel will know, what's going on and can provide feedback. So, don't sit there and if Daniel has something he mentions, you want clarification, we see this as being kind of an interactive session. So please, it's, Daniel did all this work and he'd like to share it with y'all. So pick his brain. And Daniel, I'm turning it all over to you.
Thank you, Bruce. Let's go ahead and get started. This is a process that Kentucky has come up with to locate the here link level data. And the goals of this process are to locate here links en masse to your road network, to your state's own linearly referenced data set, to screen out sources of error and not crash your computer or software along the way. Kentucky has a linearly referenced road centerline shapefile of every road in Kentucky that is maintained by our Highway Information System. And here has also provided a road centerline shapefile that has all of its speed data location. And these two sets of information are not aligned exactly with each other, and furthermore, there's no way to reference the two sets of data against each other. So in order to get the information from the here shapefile to our Highway Information System, or to your road network, the here link IDs need to be assigned a unique route as well as beginning and ending mile points.
Hey, Daniel, this is Bruce real quick. Their shapefile is based upon, what was the origin, like Census Tiger, or what were they using to develop their shapefile initially?
I don't know what their shapefile, I don't exactly know what they used, what here used to develop a shapefile initially. I think they probably used devices that actually transmitted data to them. All I know is it's off by 2 feet across the entire state from ours.
Okay.
And you can see this from looking at this map that I've created. The dotted lines is KYTC information, and the colored lines are the here data. And just for reference, the red line is a mainline interstate, the blue lines are ramps, the orange line is a state highway, and the green lines are local. And you'll see more. You'll learn more about what that means later. And here's a closer look, and you can notice how the center lines are not exactly aligned from each other. They're always very close, but not exactly aligned. So this is a problem. Now, this is an example of Kentucky's centerline shapefile that I've created. It has a route unique field that assigns a unique value to every route in the state, and it also contains the county, prefix, numbers, and suffix information, as well as some other information that's used to identify roads. For this process, it's mainly in ArcGIS 10+ with the XTools Pro extension. This extension, I was able to find at an individual price of around $250 per license, although there are also corporate licenses available. I'm not exactly sure how that works, but there's their website. You're also going to need some sort of database program such as Microsoft Access, MySQL, or Oracle, and a desktop computer dedicated to this because it will demand 100% of a computer's resources for quite some time. There were times where I basically hit run, went home for the weekend, and then came back on Monday morning for the next step in the process, and you'll see later. So the overview of this process, first we convert the here data to a series of points. Then we take the here and Kentucky data and divide that data into subsets. And we then match here point subsets to corresponding Kentucky line subsets. And then for those that don't match, we used subsequent rounds to match those points that did not match in the first round to other subsets. And from that, we find the route and mile point for each link ID. Now, the initial step, you're going to need a new ArcGIS 10 map file. you're going to have to load here's link layer, and you're going to have to remove links from the here layer with a speed category of 8. Because what I have found is that speed category 8 contains pedestrian and bicycle trails that, although it might be useful to a lot of other people, is not pertinent when you're trying to find out motor vehicle speeds. And then you're going to have to create a file geodatabase to store the results. A personal geodatabase won't do because the files that we created were just too large. Now, the initial steps, once you've loaded that information, is you go to the XTools Pro menu, and you bring up the Feature Conversion submenu and select the Convert Features to Points option. For this exercise, I used only Fayette County in Kentucky, which is a county that contains Lexington. It's I believe it's the second largest city, but we applied this to the entire state of Kentucky when we actually did this. Once the menu opens, set up the process as shown. We use the equidistant points feature to turn lines into a point file with points every 10 to 20 feet. I believe that's how it works when you do it like this. Is everyone following along so far?
Yes.
Yes.
Once you've done that, once you've utilized the Convert Features to Points feature, you're going to have to store the resulting layer in your geodatabase. And once you've done that, you're going to have to add a unique ID field to the table of the resulting layer. This is very critical because it will allow you to keep track of subsequent rounds of matching points to lines, but it's very important that you create a field with a unique object ID for every single point. And in this case, I called it ID 3, but it basically contains the object ID. In order to reduce errors in the location process, it's very important to split the point data into different layers based upon typology. For Kentucky, the here data was split into 4 different layers: ramps, limited access, arterials, and local roads / everything else. We have the information in our road center lines to do this, but here also has the information to do that as well, although they're not going to, in our experience, they did not exactly line up to our subsets. And the fields we used this were functional class, speed category, and ramp. When creating your process to locate the here data, feel free to experiment with the values in each field or other fields you may find useful. There's a lot of metadata for the here subsets. To get a subset that closely matches a corresponding subset in your linearly referenced centerline. It's important to note that the functional class field does not correspond to HPMS functional classes. I'm not exactly sure what they are based upon, but they don't correspond to HPMS functional class. Since few subsets from here will have an exact correspondent to your subset, you're going to need multiple rounds.
Daniel, this
Yes.
is Bruce Lambert. Okay, so their functional class is different, is what you just said. And
Yeah.
So what I was going to do is I'm taking notes of things to talk to Federal Highways about, and I'm going to definitely bring that point because they wanted us to do a webinar with them in October on how the states are using the here data set. So I'm taking notes like this, why the functional class is different, And I was thinking about talking to David Winter, because David Winter runs the HPMS program, and he wants to go to a national dual line network for the next upcoming HPMS submissions in the next couple of years. So there'll probably be some more changes on the network side of this going forward in the next couple of years.
Well,
I'm sorry. This is Eric Songer, DOT. We've had some discussions with them about Fun Class before, with NAVTech people, and it's a totally different thing. They were shocked to find out that DOTs used Fun Class and had a different definition. It has to do with their routing and how they route stuff, and for GPS units and things.
Thank you. There is documentation for functional class and speed category that's provided by here. And I've clipped the few pages pertinent to these fields out of their documentation, and I can provide that after the presentation. So once you've done all of that, you have to take your here points file and create your first set of subsets. And for this one, this basically tells you how to create the ramp subset. And it's very important to create this set because ramps are always in such close proximity to other roads, especially interstates. Unfortunately for us, here has a ramp field flag that flags all the ramps, and in our experience, catches just about all of the ramps that we have as well. So once you do that, you add a subset field to track subsets and fill in for each subset, for each point, what that subset is. For ramps, I just use RA. It's very important because it ensures that no record ends up in more than one subset, and it's also good for your own sanity. Once we've done that, we create a layer from the selected features, and then we just export it to a shapefile, a geodatabase. In this case, I tried to make sure everything was exported to the file geodatabase that we created earlier. Once that's done, we selected for attributes for the limited access highway. The criteria that you see here seems to work the best. Kentucky's selection did not pick up a few important limited access non-interstate highways in this set, although they did show up in the arterial set. But it also picked up a few non-limited access highways. If you come up with something better, please let me know. But this, after some experimentation, this just seemed like the one that worked best for us. And once you've done that, you fill in the selection set subset field with LA, or in our case, we just use LA for limited access. And as before, export it to your file geodatabase. Now, this is a selection set that we used for arterial roads. Again, it doesn't select all of the roads that we would consider arterials, and a few limited access highways did end up in this set, but this is about as best as I could do. And same deal here, fill in the selection set to keep track of it and export it. I think you can directly export the selection set from without creating a layer first, but this is just how I did it. The reason you fill in the subset is because creating your final local road subset, you can just select where the subset field is null, and it includes all local roads and probably a few roads that would fall in your arterial subset. And of course, you fill this in and you export it as before. Once you've done that, you've created your first subset or your first set of subsets, and all your points should be in one and only one subset. I've shown you how my layers here are organized. Now, note how some roads in Kentucky's linearly referenced centerline layer are not in the here layer. And the reverse is also true. This is just inevitable, especially with local roads, that you're just going to get some of that.
Just a clarification. Each of those subsets should be unique shape files, correct?
No, they're all part of one shapefile or layer.
Okay.
Or each subset is its own shapefile or layer. Now, for matching all of these points, we use 3 different rounds of matching. And we matched each here point layer to the nearest linearly referenced route from the corresponding subset. And I'll go into detail about how that works in the next few slides. We didn't think that ramps needed to be matched to any other subset aside from ramps because the correspondence was just really, really good. It's very important that you divide the matching into rounds so that points don't get matched to 2 different routes. They only get a chance to match to, well, one route. And that each point gets a first chance to match to the layer that its road is most likely in. So you'll see in round 1, we match the ramps. Here's definition of ramps to our definition of ramps. We match their definition of limited access to our definition of limited access, and so on and so on. And round 2, we matched the arterial roads that did not match in round 1 to the limited access, to our definition, our linearly referenced definition of limited access, and vice versa. Because I did find that there was quite a few roads that ended up in each. And for round 3, only those points that never matched in round 1 or 2, we matched from local roads, the here's definition of local roads to our definition of arterial roads, and vice versa. And this seemed to get the best results for us. For the initial round, you'll have to bring up your ARC toolbox and use the Locate Features Along Routes tool. We used a search radius of 50 feet for each point. It may sound like a large radius, but keep in mind when you're matching ramps to ramps or just interstates to interstate, it's not possible for those points to match to, say, a road that runs parallel to, say, the interstate or the ramps. Because those would probably be in the arterial or most likely local subset. So these points, by dividing them up into subsets, they never get a chance to match to the wrong subset, at least initially. And because we're only using ramps or only using points that don't match in subsequent rounds, chances are they'll never have a chance to match from, say, an interstate to a local road. Now this will add 2 fields to the table, the RID for the route identifier and the measure, or MEAS, for the mile point. And we take the results and export them to a file geodatabase. And again, it's probably better to use a file geodatabase if you think there's going to be any file size limitations. For us, our point file for the entire state was over 16 million records. Now here's the settings to locate the limited access subset. Again, you're matching, here's definition of limited access to Kentucky's limited, linearly referenced definition of limited access roads. And it's the same deal with the arterial subset, as well as the local roads subset. Once you've done all of that, and you've exported all of the resulting layers to your file geodatabase, and actually, I believe what you're going to end up with are tables for each set of matching. That's an important distinction. But once you've done that, you're going to take your results and you're going to join them to the original here points file. You're going to use the unique ID field created earlier to join each table. So this will allow you to match just the points that are in the table to the original point file. And so this is essentially looking for all points in the limited access here subset that found the line from the limited access Kentucky layer within 50 feet. The points that did not match are not going to show up in this selection set. So now that you've done that, you're going to need to copy the information from the limited access point file subset to the main point file. And you must select only for those points in the subset that matched, as illustrated in the last slide. And so the LR-RT is the linearly referenced route, just for reference. You're going to fill in the route ID information, and this window sets the linearly referenced route ID field equal to the round 1 limited access route ID field. Is everyone following so far?
Yeah.
Okay. And you're going to do the same thing with your mile point information. So same as before, you're going to fill it in with the measure or MEAS field, which contains your mile point information. And when you're finished with one subset, you basically remove the join because you're going to need to join all the other subsets and do the same thing. And you're also going to have to clear the selection, and again, repeat this for the next 3 subsets. And once you've done all of that, your first round of matching is over. And you should see that most of your points are located by now, but not all. There's always going to be a few routes that here we'll consider limited access, and your local definition will probably put them in, say, arterial. And if that's the case, there's a very good chance that it didn't locate. Whereas if they're both in the same subsets, if the actual location of your here subset is in the same subset, at least in our case of what we created, then there's a very good chance that it will locate.
I got a question. Who was it that said they had met meetings with here datasets about their routing? And when you went through and did the conversions, were they receptive to reclassifying their functional class based on what you gave them?
It was Florida DOT. And it was a couple years ago when we were in the midst of doing something very similar to this, the first time, or one of the first times. And the meeting was set up, and Jared was there. it was set up to have these kinds of discussions with them. And at first, they couldn't even get their brain wrapped around the fact that someone else called functional class something else. So, yeah, that is very well described in the metadata. No, they're not going to change theirs because they have a use for it, and that's why it's in there in the metadata, and it's explained in that metadata. But they already have a use for what they call fun class. Now, I don't know, but we were one of the, I think at the time, there weren't a lot of states that were purchasing the data from them. So maybe as more people start to purchase this data and do things like this with it, maybe they would be more receptive. But they have not been, and Jared can correct me on this because he's had more discussion than I have with him, to adding additional information for us. You think that's fair, Jared? Is he there?
Well, I know Jared said he had to leave at 2:30.
Oh, okay. So we buy the data through a third-party vendor, and or a provider. And so they're willing to talk to us, but so far we've over however many years, 3 or 4 years, 4 or 5 years, I guess we've been buying this data from them. They have not changed anything for us.
Okay.
Thank you very much. For round 2, from the original point table, you're going to select points from each of your subsets with no route information. These are the points that did not locate in round 1. And you're going to have to export them as separate point layers and name them accordingly to keep track of them. So for this one, this shows you that we're going to locate the arterial points that did not locate in round 1 to what we consider the limited access subset. So we found a few roads that are limited access by our definition, and in actuality are, that ended up in the wrong subset for here. And we're going to give them a chance to match in the limited access subset. And we used a search radius of 50 feet in this round as well. Once you've done that, again, you're going to join the table to the original point table. So you're going to join the resulting round 2 table to your original point table. And you're going to use the unique ID field again. And from the original table, we select the points that were joined. And so this should give you points that joined in round 2, but not round 1. And once you've done that, you're going to go through and calculate the route ID. The same as in round 1. And then the mile points again. And once you've done that, you remove the join and clear the selection. And you're going to repeat this until you're through with round 2. And then once you've done that, in our case, we had one more round of matching. And so you can feel free to repeat this process as often as necessary. If you wanted to, you could give every point a chance to join to every subset, or every subset from here a chance to join to every subset from your linearly referenced centerline. But it's inevitable that some points will never locate. But it's important that you always start your first round of matching here subsets to your subset that it most closely corresponds to. And the second round should match the here subset to your subset that is the second most closely corresponding subset of the remaining points, and on and on and on. Kentucky stopped at 3 rounds, but you may need more. It's entirely up to you. Once that's all done, is there any questions? Okay. Once you're done with all this, you're going to use the XTools Pro extension again, and you're going to take your original point file,
re-enable the
and you're going to export it to text.
component. It's blocking that out, but it's already allowing this.
Yeah. Hey, we need somebody to mute what they're, I think that's you, Eric, so we can hear you.
Sorry?
I was hearing somebody talking in the background to somebody else.
My phone is muted here.
Okay.
Okay. Once you've exported your original point file to text, and by the way, when you do this, you only really need the link ID, the unique ID, as well as the route and mile point fields to export. You can drop all of that other metadata because there's a lot. It'll save you a lot of time. It'll save you a lot of space. Because this is all you need to assign locations to your link IDs. Now, at this point in the process, you will have link IDs with multiple routes assigned to them. So for each link ID, let's say if it was divided into 20 points, there's a very good chance that at least 1 or 2 of those points are on the wrong route. So to settle on the one most likely route for each link ID, we will use a database program to select a route that the most points for each link ID ended up matching to. And a lot of these mismatches are just going to happen at, say, intersections and overpasses. It's inevitable. So you save the final one as a text file or a CSV or what have you. I just use a text file. And we're going to import it into Access. Now, I actually ended up doing the whole state in an Oracle database, but since I figure Access would be more illustrative than just raw SQL code, I used Access for this example. But it's most likely, if you're going to do the entire state at once, it's going to crash Access. So we import the table to Access, as you see here. Right now, we just have the link ID, a unique ID, a subset ID, a linearly referenced route, and a mile point, which in this case was named BMP, but it should, for begin mile point, but in all actuality, it should just be the mile point. And so this is the other steps to importing the table into Access. And so that's all you need. And your resulting table should look something like this. And once you've done that, you're going to create at least 2 queries to do the rest of this process. And so you're going to create a query from the imported table. It's going to be a simple query. It won't be too complicated. You're going to use all the fields. And once you've done that, you're going to have to modify it as shown. This should be pretty easy to set up in Microsoft Access, but you're essentially grouping by your link ID. You're going to count the number of points per link ID, the total number of points, and then you're going to find the minimum and maximum mile point of each link ID and route. And you'll end up with something like this. Now this, if you'll see at the very top, you'll see what I mean. There's a local road with a link ID of 233-08066. It matched to 2 different routes, but of the 15 points that it had, 1 matched to one route, and the other 14 matched to another route. Now, in our experience, the one with the 14 points is usually correct because each one of those points, let's say if it's in a straight road, probably found the same route, whereas that one point that's left over, it was probably at an intersection and found the wrong route. But in order to screen those out, we create a query of this query. And so all we're doing here is we're finding the maximum number of points per link ID, or per route per link ID. And we're also excluding all points with less than 8, all link IDs with less than 8 points total. We found that to be necessary because link IDs that were only able to generate 7 points or less were often sources of error. And I'll give you an example. Oftentimes, Navtech actually captures crossover streets from interstates. And the speeds on those small little crossover sections are very, very low. It will actually capture vehicles driving over them. And the last thing we want is a section of the interstate with an average speed of 20 miles an hour, when we know full well that it's actually closer to 70. So in order to prevent this, we just went through and got rid of everything with less than 8 points, or 7 points or less. But once we've done that, now we have a table of link IDs with a route ID, as well as a beginning and end mile point for each route. And Kentucky was able to do this for the entire state, even most local roads. So I hope you can actually see what I mean. For this link ID that's on CS2402F, most of the points are going to find the correct line with no problem. But 1 or 2 at the beginning could very well match up to the wrong route. And this is another illustration that should show you what I'm talking about. So in this case, link ID 123456 would be located to CS 1119G with a begin mile point of 15.201 and an end mile point of 17.252. The points at the beginning and the end of the link are ignored. It's important that you include null values along the way. We chose to not locate links with less than 80% of all of its points located to one route. So if you say you had 60, let's say you had 20 points total, if 12 of them located to one route, we didn't locate that link at all because less than 80% of those points were located to one route. And most of the link IDs that were not located were either short link IDs or local link IDs. But we were able to locate over 2/3 of all of our link IDs in this process as a result of this process. Now, a few additional caveats. You may need additional QC. I don't exactly know how your road network works, but we looked over ours, and this seemed to be sufficient, but if you need something additional, that's fine. The other thing is that road networks change, new routes are built, old ones are realigned, and when that happens, here will eventually catch the traffic on the new link or on the new route, and they will publish updated networks. So as a result, this is an ongoing process. But once you've done this once and cover your entire state, most of your link IDs are not going to change location significantly, and you can come up with a process that will only locate the link IDs that change location. It's something that we're working on already, but we haven't come up with a process yet that will fully deal with just the ones that change. But it's something that we're working on. When we processed the entire state at once, the resulting point file contained 16 million records. Now, I said Access would probably crash. That's not true. Access crashed. That's all there is to it. It couldn't do this. So we had to use an Oracle database to process all of this. There's always going to be small gaps and overlaps in the resulting network. And a lot of the links, and this is the only real significant source of error that we found, could very well end up on the wrong side of a divided road. But, at least it's on the correct road. Although I believe Navtech, or here, by the way, has directional information for each link ID that allows you to correct for that. Now that most of your link IDs are located, and in our case about 70%, you've got all these uses for the data. You can query by routes under your own system, functional classes, HPMS functional classes, by the way, or you can look at entire counties or cities for speed data. And this is something that we're in the process of working on. You can now compare TMC or link speed data to corresponding hourly volume counts. So in this case, you can look at speed from 9 to 10 a.m. on May the 15th versus volume count at the exact same time if you have a volume count. And there's a lot more that you can do. So with that, thank you very much. If you have any questions, you can feel free to contact me. And if you have any questions right now, I'd be more than happy to hear them. So thank you very much.
Yeah, this is great. I got a question right now, Daniel. If you,
yes.
2 slides previous on there when you said you may assign it to the wrong side of the road. Could you explain that a little bit more, please?
If you have a divided highway, at least in our case, some of the highways are divided and some of them are not. And here we'll often divide the highways at different points, or sometimes they won't.
Yeah.
And so we ended up with a lot of, but it wasn't a problem for us because we always carry the information on the cardinal side of a divided highway. So what we were able to do is to take all of the links that were located on the non-cardinal side and then put them on the cardinal side. But it is something that there's no easy way around. It's just going to happen. Now, it wasn't that big of an issue for interstates because, in our experience, the interstates are far enough apart that you can set the search radius for each point up in such a way that it won't be a big issue. But it is something to watch out for. Does that answer your question?
Yeah, I think so. So yes, it does. Thank you. But I got a follow up. So in your in the Kentucky LRS line, you've got one line, and then in here it's a divided road, and so you have a left and a right side. And generally you're following the right. You want to follow the right. Let's say the right side is the cardinal direction. The right side. Then, but you want to assign. Don't you? You want to assign both sides that route number. Is that what or the route identifier? Is that what you're?
Well, we have 2 different. Where ours are divided, we have 2 different route identifiers.
Ooh, okay. So if you have a divided like a U.S. highway that's divided but not limited access, on each set of lanes you have 2 different roadway IDs.
Yes.
Really? Cool.
Well, they differ.
What he just said was you have two IDs on each side. You're saying each two-lane piece you have a user ID.
We have a unique road ID for each direction of travel.
Okay, excellent. Okay, that clears it up. Thank you.
000 for cardinal.
Yeah, 0 10.
Are there any others?
Do you plan to post these slides to a website or make them available some other way?
I plan to send a copy of this presentation to Bruce, and I assume he will be able to distribute them to the other ITTS states.
So that was Daniel. That's what I was going to talk about. I mean, I've also, I don't have your PowerPoint or your PDF, but I also did a record. And I didn't know if, as a trial, I didn't know if you wanted to share the recording with the states as well or not.
That's fine with me.
So the answer to your question is yes. We just don't know how we're going to share it.
Yeah.
So, well, Daniel, does anybody have any other questions for Daniel? Okay, well, Daniel, it sounds like all you pretty much did was. I'm sorry.
We're good. Sorry.
I have a question for the other states. Do the other states have a linearly referenced road data for their states, or do they stop at for all of the roads in their states, or do they stop at a certain point?
Yeah, all of ours in Virginia are linear reference, and we have someone that works with the HERE data on a full-time basis.
Eric, is that in your office in planning, or is it in another office?
No, it's in my office in planning. It's not in my section. I'm in the long-range planning section. He works in the short-range planning section.
Okay.
And Arkansas is working on LRS for the entire state.
In Florida, the most of the department uses the DOT LRS, but in safety, we need to consider all roads, and our analysis routines run on a linear referencing system. So we maintain on all roads except for the roads like Daniel was talking about, or the lines in the HERE data that are not roads. We maintain a linear referencing system for crash analysis. And we mirror the state LRS for the state-maintained roads and the segments identified in our LRS, which include HBMS samples and some other roads.
Well, thank you very much. I hope this presentation was helpful, and I will be sending a copy of this, of the actual slides over to Bruce, and thank you very much.
And I guess the follow-up, Daniel, is if the states want to talk more about specific data things like this, I'm always open for ideas, and we'll try to connect and share. So hopefully this is not the last webinar we'll do on HERE or some other, kind of lifting the data to where you need to use it. So thank you, Daniel, for being the guinea pig.
Thank you.
I'll talk to everybody later.
Thanks. Talk to you later.
Thank you.